This is the High Performance HVAC podcast from National Comfort Institute. This podcast was recorded live at the AHR Expo 2025.
Good morning, everybody. I'm Adam Mufich again with National Comfort Institute, and I'm here with Mr. Craig Migliaccio.
Yep. The only guy that can actually say my name right.
I got it right.
Yeah.
I'm always nervous.
No, it's good.
But yeah, otherwise known as AC Service Tech, right?
Yep. Yeah.
So yeah, I just wanted to chat a little bit about your new book and a couple other topics in that. But I was wondering, there's so many different books that different trade schools use. I know Cengage is a big one. There's a whole slew of them, right? What made you want to write a manual like that?
So when I was teaching in the high school, right when the first year I got in, number one, I never went to a trade school myself, so I felt not good enough. And so I started reading everything that I could get my hands on, code books, the books in the classroom that were there, sample teacher books. And I was thinking to myself, how am I going to give a 15-year-old kid this 1.5 inch, huge, big, fat book that was written in a way that it didn't say procedures, and it was hard to understand. There wasn't a lot of images. So what good is that to me, as a teacher, to try to get a student to become valuable? So my whole journey of all of even the videos and books and things like that are all about trying to teach procedures so that, they can feel, see, do the action we're teaching.
Right. Yeah. So I actually had the privilege to read your book very early on, and it was pretty cool. It's called the Refrigerant Charging and Service Procedure for Air Conditioning book, right? It's
a little bit more than just read it.
Yeah.
Review it, help me make sure everything is good and correct, and give me some insight, right, into airflow situations. So I appreciate it, man.
Yeah, absolutely. No problem. Anytime you need anything like that, just give me a call. But I really enjoyed the procedural portion of the book, right? Yeah. That I think that's super powerful for, service managers, businesses in general. Like, this is not just a book for schools. Anyone, if you've been in the trade for 10, 15, 20 years, I think anyone could find benefit of it. What did you add in the second edition in this book that was not included in the first edition?
So this has A2L refrigerants, R32, R454B, in the charging scenarios, preparing the line set, if you have an existing system that you've recovered refrigerant out of, how to prepare that for the new refrigerants. But the reality of it is it's all of the procedures that have to do from pressure testing through refrigerant charging, through troubleshooting. So it's all interweaved. So it's not only the new refrigerants for, the A2L refrigerants, but it's also T's and probe use, T's and gauge stubs, like digital gauge stubs. So we really wanted to differentiate this book because we wanted to go more digital and try to have people understand what the difference is between using hoses or not using hoses. But we didn't want to, even though we would like to see as much T's and gauge stubs or T's and probe use, we still wanted to leave manifolds in there so that if a new technician starts working with somebody that only uses manifolds, we would just leave them with nothing, to start off with. So we wanted to give you the procedures for the hose, the air purging process, or preparing the hoses for refrigerant, the recovery hose setups, all that type of stuff, regardless of the way that you were going to go. But in the midst of that, you can see that, hey, we're heading towards the T's and probe use mainly. So those are the big things, but the whole object is we added 114 pages to it, added double the amount of images, but it's all interweaved through the whole thing. Towards the back of the book, it's only like 6 pages is a summarization of all of the A2L changes that have to do with residential and light commercial. So there's a quick summarization that's not just everything that's updated in the book. It is absolutely not, because it took a full year. It took a year for our whole team, the 8 people, to push this thing forward and update it correctly. Everybody from, our graphic designers to editors to, me writing it. You write a book, then you get the images, and then you have to rewrite it for the images. You have to lay it out with the images, and then you have to edit it and edit again. Then you invite your good friends over to say, hey, can you just tell me, please, because this is an important thing. I don't want to miss out anything. that's important for the industry. So that's some of the changes.
Yeah, I would tell you one of my favorite portions of the book are the illustrations. So you do a very good job of summarizing in words and describing what you need to do, but like there's pictures of everything that you're describing in the book. So it's very very detailed.
Yeah.
I wanted to ask you, what are you most proud of in the book? Like, what's your favorite chapter?
So we kind of try to do this thing where we kind of build, right? I think I'm most proud of actually the structure. So it's building to a point where then you can add these skills. I think there's a lot of information out there, but it's always a matter of how you construct it in the sequence in which you deliver the information, I think is extremely important. I'm always trying to do a thing where it's like lowering the barrier for anybody that wants to learn. So it bothers me when somebody looks at a picture and doesn't understand what's going on immediately. So if I look at something that we are producing and I look at it and I can't immediately understand what's happening, I know other people are going to have that problem too. And people think that I talk like in general, just layman's terminology to try to like bring the level down. No, that's the level at which I live at and all that. And so it's like, I also always had to work hard in school and nothing ever came easy to me. So I want it to be easy for somebody that, you know, it has dyslexia or anything, like anything. We all have a lot of things. You know, I was doing the presentation at the symposium. I had to let everybody know this platform I'm standing on, it's squeaking a lot and it's bothering me. So I'm just letting you know, like, you know, oh, that light over there, I'm like, that's like flickering, and I'm just letting everybody know, you know. Yeah. So we all have all these little things, these, you know, but we all want to learn HVAC. So the low entrance, like the low barrier for entrance, that's what I'm most proud of in the sequence.
Are you noticing, especially obviously with your first book, the new one it just hit Amazon recently, right? But are there high school programs that are actually implementing and using your book? Yeah,
and that's why it was so important. I would love to have moved on to another subject and built out some type of training and it has end caps, you know, whether it's electrical or gas furnaces or maybe making some courses, like online courses or something. And the thing is, I knew I had to do this first. You know, I've had friends that say, hey, we need to see more than manifolds. We need to see more than this. And you got to realize, like, I wrote that book 9 years ago and I didn't have friends to like review it, you know, and tell me where I'm missing the mark or something like that. But at the same time, like it seemed to make a huge difference in people's lives and stuff like that, which was what they're saying to me. And I'm like, whoa, you know, I never knew when I wrote the first edition that I never realized that the impact was going to be that big. So I had to kind of, with this second edition, it's like, it's very, very important to get that right, like extremely important because of the schools are using it, individual technicians are using it. It's kind of
I would say, you know, I told you this a few weeks back that there's a tiny little trade school near me, and I was doing like kind of a guest presentation there maybe a few months back, and they're using your book. They're using your book, and I'm wondering if there's more and more trade schools that are kind of transitioning over and trying to, you know, because I've used some of those other books. I've tried to read through them, and it's really easy to fall asleep reading them, right? and nothing against any of the people who wrote those, but it's just very technical. It's like you have to be an engineer, have some sort of a degree to follow those books, right?
Yeah, so I mean, like there is a lot of schools that are using those books, and union halls are using them. You know, refrigerant charging and the mini split book. There's the new technicians. Like our goal has always been to help the technician that just walked into a company, like they just got hired and they don't have as much education as they want, and they're thrown to the wolves. So we want to help those people out. We want to help the people that are willing to want to learn, like they're going to strive to go try to invest in themselves and they don't know where to look. Like once they land, you know, with like, you know, the information that you provide, you know, HVAC school and Ty Brannaman and like a lot of the other people that are really educating, and Chris Stevens. Like I can't. There's so many people I can't even. I hate even naming. I hate naming people.
I forget somebody.
Yeah, like that. I would like to come up with a list to try to help people out so they can filter, but I don't want to exclude anybody. So it's like that's probably why I haven't done it.
So you brought up the symposium, right?
Yeah.
You and me both, we've been to the symposium several years in a row. What was your presentation on this year?
That was heat pump refrigeration cycle. And so I was thinking, hey, we have this refrigeration cycle already built. We can tweak it. We can add metering devices. And right back there, Cal, right there in the hat, he, I know we're on a podcast and people are listening to this. So like, where? I can't see anything. I'm driving down the road and I don't see a cow. But he helped me to rebuild those and show like the single metering device heat pumps, the two metering device heat pumps, different metering devices in the outdoor unit. Some have pistons, some have TXV, some are EEV, reforming that. And, I hope he realizes too, like the impact that, he makes because of that. People are actually now able to visualize and see something that was hidden
right
in a machine.
Make it much more clear. Now, is that illustrations?
Yeah.
Okay.
Yeah, that's all illustrated. A lot of times we try to make illustrations based on the existing system, from like you have like a vision of what you want to show and you want to show it in a simplified manner. It's like sometimes with some of these things we have to leave like the distributor tubes off from where the metering device goes to the coil, or instead of showing like 3 or 4 paths in the outdoor unit, like pathways, because there's like a header and the saturated refrigerant's actually in like 3 or 4 parts of that outdoor coil. So instead, a lot of times we're just showing it from the top to the bottom when we're teaching, but we just say, hey, I want you to look inside the units to see this actually happening because it does pipe off. But the images are made so that you can easily digest the material, and you're trying to get it as close as possible to the actual system, but it has to be some interpretive parts in it too to help you learn.
Okay. Yeah. How often are you getting out and able to teach? I know you're super busy making videos. I see videos coming across all the time. You're writing books. I know you're translating your new book. It's going to be a thing that you're going to have a Spanish version of the book as well.
Yeah.
How often are you getting out and getting in front of people?
It's not as much as I would like, and it's not even. I don't necessarily love or feel. Well, I don't feel gifted necessarily getting in front of like a big group of people. To teach like, hey, a presentation, a PowerPoint kind of thing. I'm more like in the classroom, 10, 12 people, or even like at the symposium, we had a booth there. So we had books and we had all these little teaching displays. I like that. I like the 1, 2, 3 people having quality conversations, answering questions, and kind of having a more of a relational kind of education rather than me performing a show.
Okay.
Or something like that.
Yeah. What do you see as being the challenges or differences between, teaching with videos like what you do versus live? Like what's the difference? Where do some people struggle, and
what are so at least for me, so the videos, by the way, if it's like a 5 to 15 minute video, that could take anywhere from 16 to 40 hours in order to create those things. And it might not be 40 hours full of my time, but it's still like those videos all hit third and fourth reviews, like to make sure that what's being said is absolutely correct as much as I know before they get released. So there's a lot of production work. There's a lot of lighting, a lot of audio. So that's a little different than in person. But even that presentation for the symposium was, if you want to say, a week and a half of like full-time work preparing that thing. How was that? Incredible. But it actually happens, which that's not necessarily a good thing because you can't, like, I don't know. It's a hard balance. You have to adjust a lot. But you asked about, can you rephrase that question?
So I'm just wondering, like, what challenges are there, like, that you run into trying to create online content or a book versus being able to talk to somebody in person in real life, right? I know you do interact with people as they comment and ask questions to you, but like, there's a difference there. It's a little bit removed, right?
Yeah. So if you teach somebody in person, there's all of the barriers have been removed that you have to artificially remove when you are creating a video. So it is so difficult to you have to try to get lighting. You have to get the camera. You have to decide whether you want a moving camera or a fixed camera. All this stuff's in your way while you're trying to do the video. You're trying to show components, show the inside of components, show a procedure. Sometimes even though you know the procedure and you know how a system should work, The machine may not want to cooperate exactly the way that you thought, and most systems would, especially just during your video. Sometimes that happens in the middle of your step-by-step 12-step procedure, which doesn't really show like what the normal would be. It would be like an off kind of thing. So there's a lot of issues that occur with when you're trying to shoot a video versus in person. It's when you're in person, you can see this object. You don't have to worry about lighting. Everybody can see it completely. They can hear what's going on. You have to artificially get all that to that person. And I don't necessarily enjoy any of that stuff, but it's in my way.
Yeah.
It's in my way to get the information to them, so I will do that thing.
I would imagine you have to almost anticipate questions. Like, you know, they're not able to ask you questions. So as you're making the videos, you're trying to cover all those little topics.
Yeah. So you have to think about all the different questions that people have, what the search topics would be, say like on Google or whatever. Like so a lot of times we create videos based on a search term that they would use on say Google or whatever, in order to teach around that subject, because I can't get to them to teach them around that subject without first or in the middle of that answering that question that drove the traffic to the thing. So it's almost like a game to try to teach people, at least with the social media realm, until, you know, once they, you know, they know you already, and then they'll come back and you know, check out the videos themselves automatically. So it's a little bit, there's a lot of strategy involved. There's a lot of setup and trying to figure that out. So yeah, all those questions that you get asked when people come here and they ask technical questions, those get inserted into my mind. I don't tend to lose those things. So even when I was writing the book, a lot of people would say they would have questions, and I'm like, oh, we need to answer that. We need to answer that, you know. And you know, you pointed out things in reference to the airflow that I forgot, you know, like missed. You know, I'm like, oh gosh, oh my gosh, I'm glad you said that. You know, so it's like we got to get these things in there because I know that would be something that they would ask questions for later. So.
Yeah. You know, I wanted to circle back. You just brought up your book again. A2Ls has been like a hot topic the last year and a half, right? Yeah. And there's been a lot of questions on the differences between our 454B and our 32 and that, and a lot of fear, right? What are the most common questions you get, and what are maybe you could explain some of the differences between the two refrigerants?
Yeah. So the big thing seems to be what are the changes for them? Well, if you're following the procedures already, like the best practice procedures, there really realistically is only one thing that's changed procedurally wise, and that is the pre-purge with nitrogen. Meaning, like if you recover the refrigerant out of an existing A2L system, then what you need to do before you go brazing the line set again is we always flow with nitrogen at 3 to 5 cubic feet per hour with a flow regulator, not through a manifold because the pressure, you could create pinholes while you're brazing. But before you even do that, the manufacturers are recommending a pre-purge at, say, 15 to 20 cubic feet per hour for maybe 5-10 minutes or 3 to 5 minutes. And that all stems from people maybe not doing the pump down or not doing the recovery correctly. And of course, pump down is more just reciprocating compressors, not necessarily scroll compressors, but so that maybe they're not doing the recovery right. And the liquid that was left over after they reached 0 PSI has flashed into a gas, and they just don't want that gas coming through while you're brazing. So they're saying, hey, you got to do this extra step. But that's the one big, change as far as procedurally wise. I'm sure everybody has an opinion on it, and they'll say, no, there's more than just that one. But I want to take the fear out a little bit because it's getting a little ridiculous. We need to, if you don't know about the procedures already, that's a problem, so you got to know the best practice procedures. There's no flammable refrigerants in these that are A3.
Right.
They're just A2L. It also has to do with burning velocity. Like when you have a leak, the refrigerant comes out, and sometimes it comes out faster than it would even be able to carry a flame with, most of the time. And then you also have dilution, air dilution. So basically, they just want to see what things are changing. There's other things that are changing from the machine side, like pump down solenoid valves on the refrigerant tubing that'll separate the unit in half, so that if you have a leak on the indoor coil, it'll only leak out that half of the line set worth into the house, and then it'll turn you have a refrigerant sensor at the base of the evaporator coil, and you'll have a refrigerant specific sensor at the base of the evaporator coil. And those ones, that seems to be the best ones, are the thermal conductivity ones.
Okay.
They seem to be the most reliable. And actually, the first ones I saw of that realm were from Danfoss, and they actually heat up they heat up the plastic case and everything to avoid even the condensation from forming and getting onto the electronics in there. And the thermal conductivity ones, they seem to have the lowest amount of false sensing from other odors and things like that.
I was wondering, do you think, and you might not know this, maybe nobody knows this really, because the equipment's pretty new, but do you think there's going to be like a degradation of the sensor over time? Like how, I question that, if the system is 15, 20 years old, how is it going to act?
Yeah. I'm kind of curious to see what happens with the false sensing and them throwing an error and stuff over time. Yeah. Anytime something new comes out, you could have problems with it, and so there may be something like that. Yeah, for sure. There may be a thing where they're good for maybe 5 years and you need to replace them. It might be like that. I don't know what that is going to be quite yet. I don't think anybody really knows other than what they're saying from the manufacturer.
Right. Okay. Which of the two refrigerants do you think is there one that's more superior than the other?
That's a hard one. Well, it's a difficult one. I think a lot of the manufacturers switched to R454B because they wanted to get to the lower GWP number, but R32 seems to be pretty darn efficient and need a lower charge. So some manufacturers are split using it. They're using R454B for the residential systems because so many manufacturers have already switched to R454B. So they're like, we're just going to do it that way for there. And and then maybe for the commercial ones, to keep the charge size smaller, they're using R32. Even though it has that higher GWP, 675.
Can you explain what GWP is?
Yeah. Global warming potential. So that's something that would be basically make the Earth potentially warmer. The GWP of R410A is, significantly. Let me think here. I'm trying to think. So we got R454B is, what is that, 465? And then you have R32 is 675. Forgive me if I'm not getting these right because my mind's third day. What is it? R410A is around 2,000 global warming potential. It's like 1925 to 2088. Depends on which AR4, AR5, or AR6, which rating system it is. But basically, it's global warming potential. So it's greenhouse gases that get trapped in our atmosphere and kind of like hold the heat once it comes through from the sun. It kind of holds the heat on the Earth. At least that's the concept.
Right. All right. And that this actual change is a little bit different than what happened with R22, right?
It's a lot of bit different. Like actually, there's a lot more changes then than there is now. It's just that this is slightly flammable, so everybody's really kind of weirded out a little bit about that. But R22 to R410A, we're changing oils, which was a big thing. We went from mineral oil with R22, which was it would not change when it mixed with water. It was not as hygroscopic, which means like it combines with water easily. It didn't form a hydrolysis effect, which is it creates acids and alcohol, which POE oil, if you look at the base chemicals of it, is literally alcohol and acid. And so it breaks it back down into those earlier compounds, and then you have problems. So it's kind of a rough thing. Now, we also have PVE oil, which is oftentimes used on rotary compressors. And PVE oil is nice, and we've been using that with the HFCs. So let me just take a step back. R22 was a HCFC, so hydrogen, chlorine, fluorine, carbon, and that had some ozone depletion potential, and it had greenhouse gases, so it had GWP. Then we switched from there to R410A, which had R32, which is what we're now using, and R125. R125 was like it had a high GWP, but would kind of have like flame suppressant, and so it would combine as not combine. It would just be a mix with the R32 to keep that refrigerant in the A1 category. A1 or 1 is a no flame propagation. So it makes it safer, because we were afraid to go and use R32 20 years ago when Europe said, we'll do it. It's more energy efficient. It is classified maybe slightly flammable. They didn't have this classification until a few years ago with A2L. Things would fall into an A2 category. So you have A and B are like toxicity levels. So A is slightly toxic. B is very toxic, and then you have the flammability goes from 1, 2L, 2, and then 3. So it's in that sequence as you get up. It's a higher flammability all the way up at 3, and so there's some of the things. But yeah, over in Europe they were using R32 for years and never really had any problem. They didn't have to retool like we're doing now. It's like, all right, guys, how much retooling do we really have to do? We need to get A2L rated recovery machine. You're going to want to use a A2L rated vacuum pump for existing systems that you've recovered and has existing A2L refrigerant inside. You don't necessarily need any type of manifold or whatever. All of the leak detectors that we have, except for a halide torch, which we shouldn't be using anyway, is already most likely A2L rated, because there's nothing in there that would create a spark. Even in a heated diode, it doesn't go up above 1,000 degrees in order to ignite the flame. So there's nothing there to ignite. Okay. And even if it did ignite, you're moving the gas. That even has a pump in it. Right. So that gas has almost got to be stagnant, as far as it holding the flame. There's a lot of things people are afraid of with it, and I think we need to be cautious. And there could be a one-off somewhere of some problem, the perfect circumstance, which is unperfect. It's like some type of problem exists, and there's a big issue. So we're just trying to stay safe, and so it's mainly just those two tools, really, that we would need to be concerned with. If you're doing a new A2L system, you could use your standard vacuum pump. It's not a problem. I mean, you're just brand new line set, brand new evaporator coil, pull it down to 100, 100, 200 microns, run your decay test, let it run, if it comes up to 250 or 300 or whatever, as long as it's not rising, then you can just open up your lines and let the refrigerant into the rest of the system. We need to stay below 500 microns, but we try to get and pull more moisture out than just the minimum from the EPA.
Yeah. Let me ask you this. Do you think in the near future, let's say within the next 10 years, do you think we're going to start transitioning over to A3s?
In how many years, you say?
10 years.
Oh, yeah. Yeah, they're already doing it.
You see that in residential?
They're already, companies are already making the systems already.
Right, but do you think there's going to be an actual phase down of A2Ls?
If I was to guess, I think it really it does have to do with politics, all that type of stuff, which neither here nor there, but it does have to do with that. Could it happen in the next 10 years? I think it absolutely could, and manufacturers are preparing that already. So it's already happened in the where you have like an outdoor packaged unit where the refrigerant circuit's fully outside. So that's already happening, commercial. It's already happened inside your house already, or home, with 3 ounces or something very small of A3 isobutane. You have propane, which is R290. You have 600A in your refrigerators and freezers. And if all that refrigerant leaks out, it will just dilute into the air, because it has to do with like a calculation of your room size in the air. And there's never a room that's too small that your refrigerator is put in, and that's how they're able to then get that A3 into your house. And so so we already have it. But if they were to run the actual propane through the system, then there might be more solenoid valves and more cutoffs. Like if there is a leak, something like that'll shut parts off. There might be a pump down mechanism where it's going to quickly try to pump all the stuff down into the outdoor unit. In that case, it would probably just pump it down to like 5 psi or something like that. But my guesstimation is probably the same as yours.
Yeah. So seeing the struggles that we're having now, and a lot of people are nervous switching over for the first time installing A2Ls and even working on them, the dangers of them and whatnot. What do you see? Like, how do you see the country transitioning over to A3s in residential?
It really has to do. I mean, you have to have regulations, so it's not like we have to recover any A3. So there's tools already that manufacturers are thinking about. They're like, hey, if we have to recover this stuff, we're already creating the tools that are A3 rated. We don't need those now.
Right.
So you already have different companies kind of preparing and getting ready. It's just that you need the regulation, in place to say I'm allowed to do this. Of course, we have propane and natural gas in the homes, but the thing with that is it's running at or it's static pressure or whatever. It's feeding a gas furnace at a quarter of a psi for natural gas. Of course, we're measuring it in inches of water column, 27.6 water column for 1 psi. And propane is like half of a psi. It's around 13-inch water column coming in. And so you have that in the house already, or in the buildings. You might even have a high gas pressure coming in, and it's regulated down right before the gas furnaces and commercial applications. So you already have it, but in a refrigeration system or air conditioning system, it'll be at higher pressures.
Yeah.
But you're going to have a locked amount that'll be in there. So yeah. I'm kind of curious myself.
Yeah, I want to see. It would be interesting to see if we switch over to like a monoblock type system, and everyone starts kind of learning hydronics in areas that we weren't really familiar with it, or if we're going to use solenoids, kind of like what you were describing.
Yeah, I think the monoblock will be the first that gets adopted. Yes, I'm glad you brought that up, because it's so if you're basically exchanging heat with a glycol or water solution, running that into a hot water coil. But we still have to think about how we're going to dehumidify inside the buildings. So, you can even have a chilled water, chilled glycol mixture, and even alcohol, it has a better for viscosity if you could use alcohol, but that's what they use in geothermal systems a lot too. So it would be interesting to see that. Now what is nice is we're taking this approach of multiple systems in a building, as well as like if you're tightening a building up, you have mechanical ventilation now, you have a separate dehumidification system. And so I think it'll be an approach of multiple systems maybe. I don't know.
So I'm just thinking about the monoblock, and I think there's a lot of it. It really depends on the controls, but I think there's a lot. It could be quite powerful, right? Like one of the limitations we have right now with inverters is we can only ramp down so far, and when we're dehumidifying, we have a range of output, right? With a monoblock, we could have a buffer tank, so we could maintain a certain fluid temperature in that water. Yeah. And then we could use mixing valves. We could modulate our water flow to the coil. We could slow down the airflow, and it's not going to affect the compressor. So we could really dehumidify. I think there's a lot of benefits to it.
Yeah, it is very cool. It is very interesting. I mean, you think a lot of us saw the monoblocks here last year, just coming out, and so now we have another year. The manufacturers really getting on board with it. And I'm sure you'll see some regulation. That's coming down the line. I just don't know. It all has to do with the political stuff and everything, and the regulations from the governing bodies and everything. And so, and then the other thing is you then need to get it into the code books after that. So there's those types of things as well happening. I could totally see it happening in the next 10 years for sure. I think that's this R32 or 454B thing that everybody's all afraid of, and we're going to be doing it, and then we're going to say, well, that was not much, and then we're like, why did we have to learn all that? We're doing this now. I think it's going to happen pretty rapidly. It could happen before 10 years for sure. It might happen in 6. I don't know. It's hard to say.
Yeah,
I don't know.
Depends on who's in office, right? So I wanted to know, like, where do you see AC Service Tech going? Where do you see what's their next big project you're going to be working on?
Well, so presently, we just published the Refrigerant Charting as Service Procedures for Air Conditioning 2nd edition. We're trying to work on the workbook right now for that, the 1,300 question workbook. It's like a self-study kind of thing, or you could use it in the classrooms. And then we're translating that book and workbook into Spanish. So that's happening. So it's basically, I just need to build the workbook and work with our managing editor, get that done. The Spanish translations is already, it doesn't need me, we'll have different people we already have reviewing that and everything. So I can't really help anyway, because I don't speak Spanish. That's the problem. But in the midst of that, we're trying to make the decision. So I'm most people, when I talk with, I'm an outward processor. I see the needs. I listen. I try to think, like, we have a limited time on the earth. So, we have people with skill sets on your team. And so you want everybody to kind of work within their giftings. You want to build your team even more, try to lift other people up. And so you try to just kind of focus on that. What's going to make the biggest impact. So I put like a survey out on even YouTube. I haven't done it on all of our social media yet. I'm kind of just testing the waters. I said, hey, should we go towards a basics for electrical book? Should we go towards a gas furnace book? I've had conversations of trying to say, should we go into inverter heat pumps more as like a build on for the initial book, which I don't know how to necessarily like make that happen other than in an online course format type style. Or should we head into the realm of online courses in general and have like a certification of completion from us? I'm not. There's enough companies out there doing online courses for certifications things. I'm more interested in just doing the trainings. Of course, that'll come along with it if we did go that way. But I'm more interested in like a step by step. Here's the procedures. Like, this is a new technician. This is how you do the job. In the different categories. Like in a most real way possible, that's not boring, that type of thing. But that is a whole nother monster. It's a whole nother thing. It's like, hey, how do you write a book? Well, it's not that bad. I can guide somebody right through it. Well, how do you do an online course? It's like, well, I have people guiding me, but it's like, all right, well, to get these functions to work the way that we all want them to, it takes a lot more than you would ever think. Right. Some of these authoring tools, the last time they were updated is 2004. Wow. And that's why you see people doing online courses with a picture, words, and just reading it, and audio, and that's it. There's a reason why they're doing that, and it's like, well, it's because the whole structure of all the online courses online, a lot of it's like that. And we're trying to transition to try to say, no, we want to have a video, step-by-step video, and in the midst of that, have quizzes, check your knowledge, and then continue with the video, and then come out of that and have your tests, and have some, like, hey, if we're doing a project, like we're trying to teach somebody how to do sheet metal, submit some work, some pictures, in there, like, have us check that type of stuff. Let's see it, try to feel it. So we try to teach procedures in a way where somebody's learning how to apply their knowledge, and then we mix the theory in. Nobody cares about the theory until they are struggling through their procedure, and it's part of it. So everything has to be somehow applicable, so it locks it in their brain. So that's really cool getting to talk to teachers. They're like, how much percentage should you stay in the front of the class versus in the back? Like, well, you could stay in the back the whole time in the shop. Yep. And you could teach them while they're doing the hands-on. You can pause it, or you can watch them, and then they're going to come to you for the education. You'll take a pause, bring the whole team over to like watch this machine working, ask questions, and do all that, and then let them go back to their individual projects. You can come up to the classroom, but don't lock yourself in that way. I talk to some teachers where they're like, we're going to go 20 minutes here, and if I have a lot of people's questions, we're going to go right back to the shop, and once we're done there, we'll come back. Hey, get them moving. Other people are like, it's contractors at night, and they're tired, and they're sleepy and stuff. Like, you have to keep them more motivated and moving than just sitting and doing PowerPoints and things like that. It's difficult to balance.
And I know a lot of people in the trades, they like moving in general, know, like that. I struggled throughout high school and probably even before that, just sitting in a chair all day, trying to pin your eyes open. So
my grandfather was an architect, and he wanted to give me his business, but he only hand drew. And at that time, the longest I could sit in that chair was 3 hours, and that was the most painful thing ever. And even my mother disciplining me when I was a little kid, punishments didn't work. Like, the only thing that would work for me is she made me sit there in a chair with my hands folded. That was the worst thing in the world. I can't move. I can't play with something. Can't do something. I'm like, oh. So like that whole thing of like thinking maybe I would do that for a living. I would just be drawing the houses. I'm like, I have to move. I want to learn more. And as a kid, I wanted to learn everything that I possibly could. And I wanted to be somebody that people could call on and that I could help, but I didn't know that, I didn't know this, all of this stuff was going to happen in reference to that. I was just thinking like, hey, can we, just fixing stuff in people's homes? I thought that would be huge,
Yeah. Well, I have to say that you are making a huge impact on a lot of people. I'm seeing that. It's awesome to see how far you've come. I've been following you since very early on, and your books and your videos and that. I mean,
yeah. Well, you're good.
Awesome
you're a good
stuff.
friend, man, and you're kind of taking the lead on a lot of education, and you care a lot. And I think that's that right there. Anybody that wants to teach, a lot of people feel unqualified or whatever. And I know I did, coming into the classroom, and it really has to do with how much you care, how much you're going to go seek the answers. And like, I know you've always like had a deep, like, I want to make sure what I'm saying is right. And those are the kind of people that we need, like leading the charge and developing culture in the industry and education. And, people need to listen to, like people like yourself that care about not only having the information right, but how it gets delivered, because that's such a crucial thing, because you could have all the knowledge in the world and be all right in the world. It doesn't matter because nobody's going to listen. Nobody cares.
That's a good point.
It's like you have to be able to deliver it in a concise, brief way, because everybody on the earth is limited by time. They want the answer. They're searching for the answer. Give them the answer. They're trying to understand it. They're debt. They've bought a book or whatever. They paid money for it, and now they want to learn. So if they're struggling to learn by reading after even paying, so not only are they paying with their time, they've paid with money, and now they're still struggling. No, yeah. So it's like we need to lower all the barriers as best as possible. And so like, I know that those are like things like I'm concerned about. I know that's stuff like you're concerned about trying to get all the information out there in an easily digestible way, and I just appreciate that. So that's all.
Thank you. Any final thoughts?
Don't be afraid to go up and have a quality conversation with somebody, and especially in a place like here. And the biggest thing or the best thing in life that you could possibly do on this earth is to invest in a person or people in general. Like that's it. That's what life's about, is relationships. We work on machines, and we like working on machines, but if you could help somebody to learn how to work on those machines, you're going to be allowing them to be able to support their family, or if they don't have a family, it's their future family. You're helping them in life. You're helping them. You're helping their marriage. You're helping all of these things, because you're not struggling as much. You're not stressed as much, because you're allowing them to become valuable, make more money, and know how to do things. So that's it.
Awesome.
Thanks,
well, thank you, Craig. I
Appreciate
appreciate this conversation, and we'll sign off now.
Thanks, brother.
AHR 2025.
Thank you.